Guys, let's try this problem right here. Here this question is asking evaluate the integral 0 to 1 sin x over x dx correct to 3 decimal places. Now in order to do this one, first of all we have to have the integration of this one, but this is not easy to integrate this one into this pattern. So in order to integrate this one, we have to convert this into power series pattern. In that way it's easy. Now for sin x the power series pattern is always like this. So this is something you should memorize in order to solve these kind of problems. So sin x is this one. So if I want to convert this one into this pattern, all I have to do is divide this by x. So sin x over x is going to be sigma, that is a summation notation, n is equal to 0 to infinity negative 1 power n x power 2n plus 1 over 2n plus 1 factorial. This is just sin x, but here we have sin x over x. So all we have to do is just multiply this by 1 over x. So now we have converted this one into this pattern. Now if you notice, we have already x power 2n plus 1 right here, and whenever we have x power and we have x right here, and if you see, for example, if we have x cube over x, it's same as subtracting 1 from the power. Finally we will end up with x square, right? Now we can do the same thing right here. Here we have x power 2n plus 1, and if I bring this one inside, this is going to become summation notation, n is equal to 0 to infinity negative 1 power n x power 2n, and one of them is going to be subtracted. So we are going to have x power 2n over 2n plus 1 factorial. So this is going to be sin x over x. Now we are trying to integrate this one. Now we have to integrate this one. So if I integrate sin x over x, going from 0 to 1 is same as integrating this one. Summation n is equal to 0 to infinity negative 1 power n x power 2n over 2n plus 1 factorial. Now integrating this power series is very easy, because all we have to deal with is this part. Other thing is not going to change, only this part we have to integrate. Now let's do the integration. So this is going to be go from 0 to 1 summation n is equal to 0 to infinity negative 1 power n x power 2n plus 1, and then we have to divide by this power. So here already we have a 2n plus 1 factorial, and again we have 1 of this 2n plus 1 we have to divide. So this is going to be 2n plus 1 again. Now we have done the integration. Now we don't need to put this one, right? We integrated already. So this is going from 0 to 1. Now let's plug the 1. If you plug 1, this is going to become summation n is equal to 0 to infinity negative 1 power n, and x is going to become 1. So 1 power 2n plus 1, and then we are going to have 2n plus 1 factorial. Other things are not going to change because x is the only value that's going to change, right? So we are going to have 1 power 2n plus 1 and 2n plus 1. And this is when we apply 1. And when you apply 0 for this one, 0 multiplied by this one, everything is going to be 0. So this just subtraction of 0, it's not going to change anything. So we don't have to even write that. Now this is the one we are going to deal with. Now the question is, evaluate the integral correct to 3 decimal places. So we have to find a number. We have to plug some numbers. We have to start with 0 and plug some numbers, and we have to go until we get 3 zeros. So whenever we get 3 0, we have to neglect that number and add the numbers before that. That's the main concept of this kind of question. Now let's take the first term. First term we are going to have 0 negative 1 power 0, that's going to be 1. So let's put that one right here, 1, and then we are going to have 1 power, this is going to become 0. So 1 power 1, that's going to be just 1, and in the bottom just 1, and this is going to be just 1, right? So the first term is going to be just 1. Now let's look at the second term. If you plug 1 for this one, this is going to be a negative value, because negative 1 power 1, that's going to be negative, so we are going to have a negative sign. And then we are going to have 1 power 3, so this is always going to, even I think this term we can eliminate, because this is not going to change anything. No matter what value you put after 0, that's always going to be just 1, so we don't even need that one. So let's only deal with this one. So this is going to be just negative 1 power n, and then 2 power 1, that's going to be 2, plus 1, that's going to be 3, right? 3 factorial. 3 factorial is 3 times 2 times 1, and then 3 factorial, let's put the values. So negative 1 over 3 factorial times 3. So this is our second term. And if you calculate this one, you will get 0.055. Here we have 1 0. So we have to go until 3 zeros. Now let's look at the next term. If you plug 2 for this one, 2 times 2, that's going to be 4, plus 1, that's going to be 5. So 5 factorial, and this is also 2 times 2 plus 1, 5. So here you already see the pattern, that's 3 factorial, 3, 5 factorial, 5. And the next one is going to be, if you plug 3 right here, 6 plus 1, 7 factorial, 7. So that next term is going to be, and this is going to be plus, because if you square this one, negative 1 square, that's going to be plus, so this is going to be plus. The next one is going to be minus, so it will become plus minus, because we have a negative 1 power n, so this is going to alternate. Now the next term is going to be 1 over 7 factorial 7. Now let's see what we get for this one. If you calculate this one, you will get 0.00166. Now we want one more 0. We only have 2 zeros right here. So we have one more. We have to have one more 0. Now let's calculate this one. 0.000028. Now we have 4 0. So this is term we are going to eliminate. So no matter whether you get 3 0, 4 0, you just eliminate. Even if you get 3 0, you eliminate, because 3 decimal mean you eliminate, go until 3 0 and eliminate the 3 0. Since we get 4 0, if they ask for 4 decimal place, we still eliminate this one, because this is 4 0 already. So that's how we do these kind of problems. Now all we have to do is add these 3 things, and that's going to be the final answer. And if you add them together, you will get 0.9461, and this is going to be the integral correct to 3 decimal places. I hope this helps. See you next time.